On the subject of the front wheels, which we need to attach to stub axles and the steering axle, one of the prerequisites is we need to fit flanged bearings to them, and we need to recess those flange bearings into the back of the wheel. Now, first of all, I prepped the wheel by backfilling the recess with epoxy putty. This is the white fine epoxy putty, it can be any of them, because I need to provide a solid surface to take the sub-miniature flanged bearings, and I shall machine both plastic and this hardened milliput away to provide it. Now I've got to be really careful, because the one thing I do not want to do is break through this plastic. So I've measured the front to back, as it were, from that surface, back surface, to the chromed surface of the wheel, and found out I've got about 7mm, but more importantly I measured the existing bore by taking the axle out and getting some finer wire, putting the finer wire in so it bottoms out, and trimming it, and then filing it flush, so I've effectively just got a short bit of wire dropped in the hole that's flush with the top, and taking the wire out and measuring how long it is, and it's 5.7mm. So that tells me the existing hole is 5.7mm, which, since it hasn't actually come through there, I know 5.7 is a safe depth. So in consequence I want a hole 5.7 deep from that surface. Now it's a 5mm diameter hole I want, which is the diameter of the main bearing, and then once I've got that, I will then machine a bit more for the actual flange, so it sits nice neatly. Now I've got to put the wheel in the chuck. This tyre doesn't come off very easily, so I'm going to actually grip the tyre in the chuck, but it's very important that I hold it square, mount it square in the chuck, otherwise I'll end up with a wheel that wobbles, which is no good at all. So how I'm going to do that is by keeping it on the axle. Now if I spin that, we can see that the wheel is true on the original axle. So I'm going to put this in the drill chuck on my little Unimat here. So that is holding the wheel true in there, and then I can just introduce it into the 3-jaw chuck like that, and a little bit more, and tighten that up and grip it quite well, because I don't want it slipping, like that. And then first of all slacken that off and withdraw it, and then we'll just start that up. There's a little bit of wobble in the axle, but not very much, and I'm very happy to live with that. not going to get that much better. So what I now need to do is pull that out, pull the old axle out, ease it out without disturbing the wheel, and I think we've done that. I'll just, yeah, and that's still running true. So we've got that gripped nicely. I'm now just going to put a small drill in. This is about a 2.5 mil, something like that. Doesn't matter what actual size it is, but very importantly, I'm only going to put it in 5.7 mil, so I'm carefully lining that up with the face of the wheel as we've got it, and then that's 1 mil, 2 mil, 3 mil, 4 mil, 5 mil, 5.2, 5.4, 5.6, 5.7. So we can do that without breaking through. On that back, and change the drill. And now I'm carefully going to, yeah, that's still running true, that's all right. Do the same with a 5 mil drill. Now, this is the diameter of the main bull race, but of course the drill is pointy. So we're looking at what the point of the drill is doing, not what the outside diameter is doing. We cannot afford anything to go wrong with this. So 1, 2, 3, 4, 5, 0.2, 0.4, 0.6, 0.7. There we go. So we now have a hole in there, which is not really good enough because it's a tapered hole. So what we have here is an end mill, 5 mil diameter end mill, and we'll put that in. And this, with care, we can use just to bottom the hole out, but I will do that after I've cleaned the back up a bit, because it's all a bit raggedy at the moment. I'll just it will be all right when I put the tool post in its right position. The Unimat, it's an old lathe. This particular one is more than 35 years old, and I've had it all. I've had it from new, and it's a delightful little lathe for small work. I've remoted it, so what we're doing now is just getting rid of the excess plastic and the excess milliput. To bring us to the back of the real wheel, if you see what I mean. Let's have a look and see what we've got. Right. Now if I lean the camera in, you might be able to see the not really, no. But the bore has a drill-shaped tapered in it, taper, and we have to get rid of that. So we're going to be doing that with the aid of this end mill in the drill. Let me just wind that out. Again, we have to be so very, very, very careful not to break through in any way, shape or form. And literally just square, what we want to do is just square the bottom of the hole off. Just gonna, sorry, the camera didn't even get to see that. I'm just gonna see if I can see what's going on in there. Now then, I want to remove a bit more of the milliput from the surface. Camera's telling me I'm panning too fast. Of course I'm panning too fast. that's probably not too far off. Now I'm going to take a teeny bit more off. There's so little to play with here. And that's as far as I'm going to push my luck. Right. Where's me? Can't see for... There we go. Just going to take that right off. There we go. And let's have a feel of a bearing in there. Yeah. Right. Good. Now then, let's have that out. Now what we have there, left over from the end mill, we have a stub in the centre, and that's getting in the way, and that we can just ping off the scalpel or indeed any other tool. Because the end mill has 4 cutting tools and it doesn't cut in the absolute centre. Right, so let's feel that. Yes, and there we have, if I let the camera settle, the bearing sits very nicely in a recess made for it, and very importantly, if you can see that against my finger, you can see that it nestles fairly close to the steering arm, and the centre of pivot is pretty close to the wheel. So we're keeping the 4.5 travel as small as possible. Now on a big commercial vehicle, a big lorry, that kingpin almost disappears into the wheel. It certainly sort of lines up with the back of a tyre. But on a small car like this, the tyre's narrower, everything's smaller, and we're not going to get it any better than that without actually breaking through the wheel hub, which we've avoided. I have a device here for measuring how much meat is left there, and in fact there's 1.5 millimeters of meat left there, so in theory we could have gone a little bit thinner, but one doesn't want to push one's luck too much. So that's the process of dealing with a wheel, prepping a wheel ready to fit to an axle, be it this axle or the one that's printing.